Welcome to Module 2, which is on compound interest and installment buying. Those are sections 7.4 and 7.5. So we're going to start with 7.4 and talk about compound interest. So the last module we talked about simple interest. And we talked about how, one example might be if you're investing some money, maybe you put money into a bank account, you could get some money just in exchange for leaving your money in that bank account. Well, with simple interest, you're only gaining money, additional money on the original amount that you put in the account. So for example, if you put in $1,000 and it's there for, 5 years, you're only gonna earn interest on that $1,000 that you put in. Compound interest, on the other hand, is better if you're investing because you're going to earn money on that original amount, and then that amount is going to grow as you earn money. So say, for instance, you put in $1,000 and then it's there for a couple months and maybe you earn $30 in interest. Well, now instead of $1,000 in your account, you have $1,300 in your account. Well, the next time you earn interest, you're going to earn interest on that 1,300 and not the 1,000. And so basically it keeps compounding. That's why it's called compound interest. Every time you gain interest, it's on the current amount that you have as opposed to the original amount of money that you put in the account. So your money can grow a lot faster when you're getting compound interest compared to simple interest. And if compound interest is being taken on money that you owe, so maybe like a credit card, it would be worse for you because you'd be paying a lot more interest. So let's jump in and let's do an example. So one thing, a couple things that I want to note before we do an example. So there's the compound interest formula, which is right here. And let's talk about what each of these things mean. So A, we consider the future value. That's the money that you have in the end. So by end, I mean like after you invest it or after you're done paying for something. P is principal. That's the original amount. Rate that's going to be your percentage rate but in a decimal. So for instance, I'm just going to put, for example, if it were a 5% interest rate, you would put in 0.05 for R. And then N is going to be the number of times per year the interest is compounded. So in this paragraph above, I listed off different types of compounding and what that would mean in terms of the end value. So if it's compounded yearly, then we say n equals 1. If it's semi-annually, twice a year, then that would be n equals 2. 4 times a year, n equals 4. That would be quarterly. Monthly would be n equals 12. Weekly would be n equals 52. And daily, n equals 365 because that's how many days are in a year. So you can kind of go back and reference that if you need to as you're doing these problems. The other thing that I want to mention, and it's not in this chart, I think it actually, I meant for it to be, but it's hiding behind the box here, is T. So T is time, but it's time in years. And honestly, out of anything here, that's what you want to highlight in your notes because there are some problems where they give you time in months and it's really easy to just make the mistake of just putting in the number of months and then you get the problem wrong. So make sure if you're given the number of months, you have to convert it to years. So let's jump into the example. So it says find the interest on $7,000 compounded quarterly at 3% for 5 years. So $7,000, that's the original amount that you're putting into this investment. So that's going to be your P value. And then it's compounded quarterly. So that's N equals 4 times a year. 3%, so that's your rate. But as a decimal, remember we always take our decimal, which is always at the right of the number if we don't see it already. And we're going to move it 2 spots to the left and fill in any blank spaces with zeros. So it's going to be 0.03. And then for 5 years, so that's already in years, which is great, we just put 5. So now I'm going to write down my formula. So A equals, and I'm using this formula up here in the box, I'm going to do my P, so 7,000 times 1 plus my rate, 0.03, divided by 4, and then to the 4 times T power. Now, there's a couple different ways you could do this. If you want to, you could do one step at a time and write down the results on paper. So this is how that would look. I'll show you. So the first thing I would do is I would do the exponent. So I would work and do the order of operations. So I would do 0.03 divided by 4. 4 times 5 is 20. Then I would do the inside of the parentheses. So 1 plus, if you divide 0.03 by 4, you get 0.0075 to the 20th power. Then I still want to do the inside of the parentheses. So I'm going to do 7,000 times 1.0075 to the 20th power. Next, order of operations say do exponents next. So I'm going to do 1.0075 to the 20th power. Let me show you how you do that on the calculator. So why is this not working? There we go. 1.0075, and you're going to use the exponent key, which is on the left here. It looks like a little arrow, and then to the 20th power. Enter. Okay, so we've got that result there. Oh, you know what? Got the wrong answer because I forgot the 5. Let me do that one more time. So 1.0075 to the 20th power. Okay, that looks good. So then I'm going to come up here and I'm just going to write down my result. 7,000 times 1.161184142. And in my calculator, I can just leave that answer up because it's already there, so I don't have to type it in again, and then just say, whoops, I want to go back here. I'm going to hit the delete key because I did times too many times. So times 7,000, enter, and then I've got my answer. So my A value here, future value, is, and actually I'm going to do approximately, $8,128, and then you're going to have to round all of these values for compound interest to the nearest cent, just how you would do money, so 2 numbers after the decimal place. So in the calculator it says 0.288, so since that's an 8, second 8 is going to round that up to 0.29, and that's going to be the future value. Now that's important. So I'm going to just circle that, but that's actually not the answer because the question says find the interest. If it said find the future value, then you'd be done. But they want to know, well, how much interest did you earn? Well, if you put $7,000 into an account and you came out with $8,128.29, in order to find the interest, you're going to have to subtract those. So if you like using formulas, the formula is interest equals the future value minus the original, which is P. So you're going to do 8,128.29 minus 7,000, and then you get $1,128.29. So that is going to be your final answer. So I'm just going to circle that in red. I want to show you real quick another way that you can put this in your calculator, and I think this is super handy. So with the TI-34, what you can do is it's got an N over D button, which is a fraction button. And it's over here on the left hand side. If you click on it, whoops, I clicked on it too many times. Let's do that one more time. Okay, it gives you a fraction. You can actually, you can see that there's a fraction in the problem here. You can use that N over D button and allow, and it allows you to put this whole entire thing into your calculator at once. So let me go ahead and clear, and I'm going to start by putting 7, whoops. Bear with me, my keys on my computer are super sticky. Okay, 7,000 times 1 plus, and this is where I'm going to use that N over D button, N over D, 0.03 down 4, and then you have to use the arrows to get out of that fraction. So you can see how the cursor is down below. You want to use the arrow to get out of that, and then end parenthesis. And it's cool because the parentheses, they just grow. When it gets bigger on the inside, they match the size that it needs to be. So then we're going to do the exponent key, so this arrow, and then you can even type in 4 times 5. And if you want to put 20, put 20, but you can honestly, so I just put every single thing in exactly how it looks on my paper. I didn't calculate anything ahead of time, and then I hit enter, and you can see I end up getting the exact same answer. So I would actually suggest, if you're comfortable with a calculator, then I would do it this way. I think that this is a great way to do it. I know some of you probably, some people just like to show your work, so definitely, you know, you've got that as an option. And then just real quick, I'm not going to use the graphing calculator on a lot of these, but I just want to show you one time in case you do have a graphing calculator. This is the TI-84, and this will also work on the TI-83. You can, or it should, I believe. I actually have to go look that up. If you go to the math button, and you scroll over to fractions, you can use the right arrow or just I can go left. The very first option is n over d. If you hit enter, that's how you get that fraction there. So you can, with a graphing calculator, enter in the entire equation just as we wrote it out on that first step using your graphing calculator. So just a heads up on that. Okay, so let's scroll down here. So we're going to talk about annuities next. So annuity is a special type of an investment where the same regular payment is made into a compounding account. So that could be like, let me give you an example. Let's say that you wanted to save up for a car and you knew that in, 5 years you wanted to be able to buy a car. What you could do is you could take out an annuity, which is an investment, which would allow you to give money to the bank for the next 5 years and earn some money. So that way, let's say you want to buy a $5,000 car, maybe you only have to put in a little less than $5,000, and the interest that you would earn would bump you up to that $5,000 amount. So it would allow you to save a little bit of money in exchange for making regular payments until that point. And then it's also a really good way to just save money because you're sort of forced into making these regular payments. So there's 2 different types of formulas, and they're really the same exact formula. They're just solved for different variables. So for example, like if I had an equation x equals y plus 4, I could rewrite that by subtracting 4 from both sides and write it as x minus 4 equals y. And this equation and this, they're essentially the same thing. They're just rewritten so that different variables are solved for. And that's the exact same thing we have here with annuities. So these are really big formulas. We're going to definitely rely heavily on the calculator here. So the first formula is solved for the future value. So you're going to use this if you want to use this only to find future value, and that means you're given the regular payment. So if the problem gives you the regular payment amount, which is R, you have that to plug in and you want to find the future value, you use the first equation. For the second, you're going to use this formula if you're asked to find the regular payment. So you're finding the regular payment and you're given the future value. So let's go ahead and we'll do this next example, and I'm just going to see, let me see if I can scroll up just a little bit so we can see those formulas. Perfect. Okay, so this example says find the future value. So if you're asked to find the future value, then you want the equation that begins with the A. So you want this equation where you've got R okay, and then let's go ahead and I'm going to scroll up now that I wrote that all down. Let's go through the problem and determine what number goes in which variable. So if the payment is $800, it doesn't say regular there, but that's what it's referring to. So payment, that's the regular payment. So R, big R, is $800. It's compounded semi-annually, so that means twice a year. So it means that N is going to be 2. The rate is 5%. So R equals 0.05 because 5%, we move that decimal 2 spots to the left to get 0.05. And then the term is 4 years, so that means T equals 4. So we're going to go ahead and plug in all those numbers. So, and then just keep in mind, so the brackets, those are the same thing as parentheses. I know sometimes it's easy to get tripped up and think, oh, these are like, they mean different things. They really don't. It's just to distinguish and make it easier on the eye so that you know like this bracket bracket goes with this bracket, and this parenthesis here goes with this one. So making it easier to match up. So when we put it in our calculator, you're just going to use parentheses for where you see the brackets. So our regular payment is $800 times 1 plus R over N to the N, which is 2, times T, which is 4, and then minus 1 divided by our rate, 0.05, divided by 2, because that's our compounding period. So this is where this calculator is really going to shine here with this N over D button. So I'm going to hit the N over D button, and I'm going to type everything as I see it. So 800, and then instead of a bracket, I'm just going to use a parenthesis. So 2 parentheses, because I have a bracket and a parenthesis, and then 1 plus, I'm going to use the N over D button again, and see how the parentheses just got bigger there, so it just adjusts, which is nice. So 0.05 divided by 2, and then make sure you use the right arrow to get out of that fraction, and parentheses, and then you're going to use the exponent key to go up top. 2 times 4 is 8. You can certainly just enter in 8 there if you want. I'm just going to show you how to make the calculator do everything. Now see how the cursor at this point is up above with the exponent? You want to use the right key. Whoops, I shouldn't have hit up there. Let me go back to where I was. You're going to use the right key to get down below. Oh, is this? Hopefully this is not stuck. Okay, it's not good. Okay, so bear with me here. I just got to click over to get back where I was. Okay, so now I'm down here. I'm going to do a minus 1 and then bracket. And then I'm going to do the down arrow to get down below, and then I'm going to push the N over D button again because I have a fraction in the denominator, 0.05. Oh, it didn't register the 5. Let me put a 5 in there. So 0.05 and then 2. Okay, and then I just give it a quick once over and make sure that, I mean, like me, it's just so easy to mistype the numbers here. So you can see most of them. You can use the right arrow to go to the right, so that way we can see the end here, -1. And so that all looks good. It all looks like what I have on the paper. And then I'm just going to hit enter, and then I've got my answer. So my answer, and we're going to round to 2 numbers after the decimal place, is going to be $6,988.89. And at this point, if you get it wrong, there's really 2 places to look. It's entering it in the calculator. That could be one place. And then look at how you look at the formula you picked. Make sure you pick the right formula. And then also go back and look at all of the numbers you put into the variables and make sure that those are all correct. So there's really 3 main places that you can make mistakes on this problem. And then remember, if you have a graphing calculator, use that N over D button on the graphing calculator as well. Okay, so let's jump down to, we're going to talk about effective rate. So effective rate, or sometimes it's called annual yield, is the simple interest rate that would yield the same future value over 1 year as the compounded interest rate. So the reason why this is nice is because, say for instance, you put money into an account for a year, and let's say the account is compounded interest, and let's say the rate is 4%. Well, since it's being compounded, let's say it's being compounded a couple times a year, you're actually earning more interest than the 4% because it's being compounded. So this effective rate formula allows us to see what the percentage rate actually is in simple interest terms. So let's go ahead and do an example. So it says find the effective interest rate when the stated rate is 4%. So they say the rate is 4%, so that's 0.04, and the interest is compounded semi-annually, so N equals 2. So I'm going to use this formula, effective rate, 1 plus my rate, 0.04, over N, which is 2, to the nth power, so 2, minus 1. So you could work this all out by hand, or I'm just going to go ahead and I'm going to type that right into the calculator. So I'm going to use parentheses. Whoops, sorry about that. Okay, so parentheses, 1 plus N over D button, 0.04, down arrow, 2, to the right, parenthesis, raise to the second power, and then right arrow so I come out of that exponent, and then -1. Make sure you come out of that exponent when you put the -1, and then enter. And so I end up getting 0.0404. Well, what is that in terms of a percentage rate? So if I move that decimal 2 spots to the right, it's 4.04%. So what this says is if you have an interest rate of 4% and you're getting compound interest, it's really like you're getting 4.04% simple interest because of that extra boost that you get from that compounding. So this allows you to compare apples to apples if you're comparing, if you want to compare like a compound investment to a simple investment. So that's all in terms of 7.4. We're going to jump into 7.5, which is on installment buying. So installment buying just means you're buying something by making payments instead of paying for something all up front. So anytime you have a fixed installment loan, which is this first term here, it just means that you're being loaned money to purchase something, and in exchange you're being asked to make regular payments. So let's say you want to go and buy a couch, and they might give you a loan to buy the couch, and then over the next year you have to make payments on the couch. The exchange is that you actually pay more for the couch than what the couch is advertised for, because you're going to pay interest on that money. So it works for you because you get to buy something that maybe you don't have money for. And then it's also very advantageous for the person loaning you the money because they're getting extra money by loaning you this money. So down payment would be money that you give to the lender, the person lending you the money up front. You're not being charged interest on this because you're giving them the money right away. The amount financed is the money that you're actually asking to borrow, that you're paying interest on. And then the total installment price, this is a big one. So that's the total amount paid for the item, because sometimes it's easy to think that when we finance stuff, we just think of the cost of the item at the beginning. So say for instance, we buy this couch, and let's say it's $1,000 couch, and we think, okay, my couch is $1,000. Well, if you're making payments on it, it's really not $1,000 couch. It's probably like a $1,300 couch because you have to pay interest. So we're going to think about the whole price, not just what's advertised. And then the finance charge, that's the money that you end up paying in interest in exchange for this loan. So let's go ahead and do an example where we calculate a car loan. So Kat bought a 2-year-old Santa Fe for $12,260. Her down payment was $3,000, and she will have to pay $231.50 for 48 months. Find the amount financed, the total installment price, and the finance charge. So we're going to do one thing at a time. So the first thing that we're going to work on is we're going to work on the amount financed. So the amount financed is the amount that she's asking the loan for. So let me just scroll up real quick. So if she's paying, let's see, if the car is $12,260, that's how much she would finance if she didn't put a down payment down, if she just wanted to borrow that whole amount. But she doesn't, because she makes this down payment of $3,000. So we're going to take off the $3,000 because she has that money up front. So we're going to subtract that $3,000. Whoops. And so we get $9,260. So that's how much, that's called the amount financed. That's how much she borrows from the bank. So it's advantageous to, whenever you're buying something with payments, whether it be something small or big like a house, the more that you can put down, the better, because it means you're borrowing less money, and that means less money that you have to pay in interest. So the next thing that we're going to do is we're going to find the total installment price. So step 2 is total installment price. So we want to know how much does she actually pay for this car. So we know that she pays this $12,260, but she's going to actually pay more than that because she has to make these payments. So what we're going to do is we're going to take her payment amount, $231.50, and I'm going to multiply that by the number of months that she pays it. So she's going to pay $231.50 times 48 months. And then she also ended up paying that down payment amount. So she makes, these are her payments that she pays over 48 months. And then this is the down payment. We don't want to forget about that because she paid that up front. So we want to add all of that together. And then if you do that, you get $14,112. And that's the total that she pays. So again, check out the price of the car. The car is a little over $12,000. She ends up paying over $14,000 because she ends up paying some in interest. And then the third one that we're going to find is the finance charge. So that's the amount in interest that she ends up paying. So we just figured out that she paid $14,112 for the car. Let's subtract the cost of the car. So this is the total installment price, and we're going to subtract the cost of the car to see how much extra did she end up paying above and beyond the cost of the car. And if we do that, we get $1,852. So she paid $1,852 just in exchange for making payments. Had she had all of that money up front, she would actually have saved $1,800. So, and you know, it's common to have to make payments when we buy things like cars, but it's just good to know what you're paying in the end. So let's do another one. This is similar. Instead of a car, Max is buying a computer for $950. It looks like he made a down payment of 20%. And it asks us to find the monthly payment if the finance charge was 5% of the amount financed. So this is a different type of problem because we're actually going to compute the finance charge. So the first thing that we're going to do here is we're going to find the down payment. So it says that the computer is $950. And it says he made a 20% down payment. So I'm going to take 0.20 because 20% as a decimal is 0.20, and I'm going to multiply that by 950, and I get $190. That's going to be the down payment. Next, what I'm going to do is I'm going to figure out the amount that's financed. That means how much he's borrowing from the bank. Well, if the computer is $950, but he has $190 to put down, then we're going to subtract that to figure out how much more he needs. So if you subtract those two numbers, you end up getting $760. So that's how much he's going to borrow from the bank. And then now we can find the finance charge, because we couldn't have found that until we actually know how much he's borrowing. So the finance charge is going to be the amount financed, which is $760, times the percentage rate of the interest. Now this is where these problems can be tricky, because notice there's 2% in this problem, and you got to read really carefully. There's 20% and 5%. 20% is the down payment. The 5%, that's the finance charge. So I'm going to multiply 760 by 0.05, and that gives me $38. So that's how much money, in addition to paying for the computer, he's going to have to pay for the item just so that he can make payments. And then we want the monthly payment. So in order to get the monthly payment, I'm going to want to figure out how much he's going to have to pay to the lender. So I'm just going to write total owed to the lender. So he's going to have to pay back the $760. That's how much he borrows. And then he's also going to have to pay that finance charge of $38. And so we're going to add those together and get $798. So that's the total that he ends up needing to pay back. Now we can find that monthly payment. So step 5, the monthly payment, is going to be that $798 divided by, so this number just comes down here, the number of months. And it said in the problem 30 months, so we divide by 30 and we end up getting $26.60 per month. And I'm sure, we all know that the monthly payment always looks better than the original price. So usually when we're at the store, we skip all of these calculations and we just jump to the monthly payment. But it's really important. I just want to highlight here the numbers that are important are the total amount that you're paying here, that 798, well, plus that 190 that you already paid in the beginning, which ends up being much more than the actual cost of the computer. So it's just good to know. Okay, so the next problem we're going to do is figure out the annual percentage rate. So it can be really tricky when you're taking out a loan for something to figure out the true interest rate that's charged on the loan. And it's by law, credit card companies and lenders are required to advertise an APR, annual percentage rate, and that allows us to just make good decisions about what we're borrowing and what loans we take out, maybe what credit card you want to get. You always want to find the one with the APR that's the lowest. So we're going to actually figure out how to calculate the APR, and we're going to use a table to do it. So, and keep in mind when you do your homework, you're going to have access to this table, and same with your midterm and final. So it's nothing you have to memorize. So there's a formula, and we've got some steps here. The first thing, your formula is right here. So let's start there. I'm going to scroll down and we can come back to these steps if we need to. So in the problem, finding APR, Bert Carter purchased a color laser printer for $600. He made a down payment of $50 and financed the rest for 2 years with a monthly payment of $24.75. Find the APR. So anytime a problem says find the APR, we're going to write down the APR formula. So the APR formula is the finance charge divided by the amount financed times 100. So let's first start there. That was step one. So the first thing that we're going to do within that formula is we're going to find out the amount financed. So if the printer is $600, he could finance all of that unless he makes a down payment, which he did. So he made a down payment. So I'm going to take that off of that $600 because he doesn't need to borrow all of that $600. He only needs to borrow $550 since he put $50 down. So $550 is going to be the amount financed. And then the finance charge. So finance charge, that's going to be that additional amount that he pays for the, just in exchange for paying for the item. So I'm going to take that payment amount, so $24.75, and I'm going to multiply that by 24 because 2 years is 24 months. So I want to make sure to convert that to months. So $24.75 times 24 months. Okay. And then I'm going to add the $50. So I'm going to come over here, my calculator, and I'm just going to do 24.75 times 24. So he ends up paying $594 over those 24 months, and then he also made that down payment in the beginning. So I want to add that $50. So he ends up paying $644. That's like the total installment price. That's the total that he ends up paying for the item. Well, to find the finance charge, what we're going to do is we're going to take the total installment price and we're going to just subtract the price of the item to figure out how much extra does he pay just for the exchange of borrowing this money. So he pays $644 for a $600 printer. So we end up paying $44 extra. That's the finance charge. So the third step is we're just going to go back to that formula and we're going to plug everything in. So the finance charge is $44 divided by the amount financed, which is $550, times 100. Okay, and then we're gonna, so I'm gonna plug that all in my calculator. So I'm gonna come over here, and I'm gonna do 44 divided by 550, enter. I could use the N over D there, N over D button. Not necessary though, so it's fine to do it this way too. You get the same answer. I end up getting 8. Now, you're not always going to get an exact whole number, but we did in this problem. So the next thing we're going to do, and the steps are above the table here. So we just did step 1. We use this formula, and then you're going to find the row in the table marked with the number of payments, and then find the closest amount to what we found using the formula. So if in this case, there's 24 payments. So over on the left here, this is the number of payments. So 24 payments. I'm looking at this row right here. And then I'm going to find the number that's closest to $8. So in this case, there actually is a value that's $8. Sometimes it's not exact. Sometimes, like say for example, let's maybe say I got 7 there. If I got 7, I'd be right in between these two numbers. Well, I'd be closer to 691, so I would choose that one. So you always just choose whatever's closest. In this case, $8 is actually on the table. And then what you do is you just look directly up. And that's going to be your APR. So when I look directly up, it's 7.5. Let me just scroll down just a little bit. There we go. And so the answer is 7.5%. That's the APR. So let me just go back and review real quick. So we are going to find the number of months on the left-hand side. We identify the row that we're looking at, and then we find the closest number in that row to the number that we got from using the APR formula. And then we look up, and that's going to be our APR. So the annual percentage rate for this laser printer is 7.5. And how is this helpful? Well, if he was shopping around at different stores, he might ask for the APR and maybe want to buy the printer at a store where it had the lowest APR possible. Okay, so let's just scroll down here. We're going to move on from APR and we're going to talk about a different type of credit. So open-ended credit versus close-ended credit. So up until now, we've been talking about close-ended credit. So when you take out a loan for a printer or a computer or a car, that would be close-ended credit because you're being loaned a certain amount of money, you have a certain amount of time to pay it off, and that's it. Like you have to pay it off by that time. If you don't, then collection agencies are going to try to collect that money from you. They're not going to negotiate, and give you more time. Open-ended credit, for example, is like a credit card. So credit cards are open-ended credit because credit cards don't have any fixed payments or payoff dates. Now, usually they'll have like a minimum payment, but it's not a fixed payment that you have to make every single month. And it's open because there isn't this end date that you have to be finished with this credit card. So there's a couple different ways that you can calculate credit card interest. So the first method is called the unpaid balance method. And when you're doing your homework, you just really have to make sure you're paying attention to what method you have to use in the problem. So, and they're going to be they're longer problems, but I promise you they're going to be all very similar. So as you're doing your homework, just come back to this video and this problem, and you should be able to look side by side with your homework. And it should be a huge help. So with the unpaid balance method, just a quick note here, you're always going to calculate, so always calculate the finance charge from the previous month first. So first is in capitals because that you have to do that first. If you don't, you're going to get the wrong answer. So let me show you what I mean. So let's look at this problem. So for the month of April, Elliot had an unpaid balance of $356.75. So before I even keep reading, that's the balance that he had from the previous month. The first thing that we're going to do is calculate the finance charge based on that amount. So finance charge, I'm going to write down $356.75 and I'm going to multiply that by the interest rate. So you want to read through the problem and find the interest. So the interest on the unpaid balance is 1.8%. So 1.8, if we move the decimal 2 spots to the left, would be 0.018. So I'm going to multiply that unpaid balance by 0.018 and I end up getting 6.4215. You always want to round to two numbers after the decimal place. So 6.42 because there's a 1 here, which tells us to leave that 2 alone. So $6.42, that's going to be the finance charge. So now I want to find, that was the finance charge based on the balance from April, that remaining balance, because when you leave money on a credit card, you end up having to pay finance charges. If you pay your credit card off every single month, which is ideal, then you don't ever have to pay finance charge, and so you don't ever have to pay any extra beyond the cost of the items that you buy. So now we're going to find the balance, the new balance on May 1st. So we're going to start with, so this is going to be step 2. We're going to start with the balance, so 356.75. Okay, and then I'm going to go ahead and read through the problem. So it says he made a purchase of $436.50. So purchases are going to add money. So I'm going to add, this was a purchase. A payment of $200 was made. So payment, I'm going to take off $200. Payments, we subtract. And then I'm going to add that finance charge. And the finance charge was $6.42. So you start with the balance. Okay, you add any purchases, you subtract any payments, and then you make sure to add in that finance charge. And when you tally that all up, so add and subtract those, you end up getting $599.67, and that's your final answer. So how I added and subtracted these, the order really doesn't matter. You get the same answer, but just make sure that you calculate that finance charge at the very beginning. Because if we were to take 18% or 1.8% on this $599 number, or even a little bit less if that finance charge wasn't calculated in, we'd get a different answer and it wouldn't be the correct answer. So the next method is called the average daily balance method. Now this is a long problem, so bear with me here. It's the last problem in the section. I wouldn't say it's hard necessarily. It's simple in a sense, but it's complex because there's a lot of steps. So there's a lot of places where you can make a mistake. So I would just, go slow and try to be really careful when you put numbers into your calculator. So the first thing we're going to do is we're going to start with this chart, and I would make a chart like this when you do the problems on Connect. So on August 1st, we had this balance of $165.50. So I'm just going to move that over. So our beginning balance is $165.50. So for the first row, you just move over the balance. Days means how many days was that balance on the credit card. So if it was the balance on the 1st, and then on the 7th we made a purchase, then that was the balance on the 1st, the 2nd, the 3rd, the 4th, the 5th, and then the 6th. Not the 7th, because the 7th they made a purchase and it changed that balance. So that it was the balance for 1, 2, 3, 4, 5, 6 days. Okay. A quick way that you could do that would be to take the 7th, 8-7, minus 1, the 1st, and then you end up getting 6. And then balance times days, you're going to multiply 165.50 times 6. You multiply these two numbers. Okay, we multiply those and we get $993. Okay, next. So now we're going to find the balance for August 7th. So a purchase was made of $59.95. So I'm going to add that. I'm going to go ahead and I'm going to add these together. So I'm going to take that previous balance of $165.50 and add $59.95, and I'm going to get $225.45. So $165.50 plus $59.95. And then the number of days. So if that was made on the 7th and a new one is made on the 12th, this would be the balance on the 7th, on the 8th, on the 9th, on the 10th, and on the 11th. So 1, 2, 3, 4, 5 days. And then I'm going to multiply those two, the balance times the days, to get $1,127.25. Okay, the next one, I make another purchase. So I'm going to add that number, $23.75, to the previous balance of $225.45. So I add those together and I end up getting $249.20. the number of days. Now you could do 18 minus 12 and get 6, or you could actually write it all out. So the 12th of August, the 13th, the 14th, the 15th, the 16th, and the 17th. So 1, 2, 3, 4, 5, 6 days, because the 18th we made a payment, so that's 6. You multiply the balance times the number of days, and then you end up getting one, oh, you know what? Let me see. Yep, I'm just looking at my answer key here, making sure I don't make a mistake. $1,495.20. Okay, cool. And then the next one, so we make a payment in this one. So I'm going to take my previous balance, $249.20, and now I'm going to subtract. So let me just get a different color. So the reason I subtract here is because I have a payment. The rest were purchases. So that's why I was adding previously to this one. So I'm going to subtract $75 there, and I get $174.20. And then that's the balance that was on the 18th of August. So the 18th, the 19th, the 20th, the 21st, the 22nd, and 23rd. I'm not going to include 24th because there was a purchase there. So that's 6 days. And then I multiply 6 times 174.20 and I get 1,045.20. And then last but not least, I have a purchase. So I'm going to add that 107.43 to my previous balance of 174.20. And then I get $281.63. Now, the last box, number of days, it's really important. Well, two things. One, you need to know how many days are in the month. So in this case, it's August. So there are 31 days in August. So this goes until August 31st. So if we use our trick of subtracting, which I don't always recommend because it can trip us up on this last one, 31 minus 24 is going to give us 7, which doesn't give us the right answer. We want to actually include the 31st since no purchases or payments were made on that day. If this is confusing, one thing you can choose to do is just write it out. So on the 24th we have that balance, and the 25th of August, and the 26th, and 27th, 28th, and the 29th, and the 30th, and the 31st. So that leaves us with 1, 2, 3, 4, 5, 6, 7, 8 days. And then always double check, add your number of days, and you should get the number of days in the month. So I would say this is one of the biggest places that people make mistakes, is they just mess up one of these days boxes and it throws everything off. So add this up and you should get 31. If not, then go back and see if you can find your mistake before you move on, because it will throw you off. The next thing we're going to do is we're going to find the average balance. So I'm going to add up. Oh, you know what? I forgot a step. Never mind. One step back here. We forgot to put in that number. So we're going to multiply 281.63 times 8, and we get 225304. Okay, now we're going to find the average daily balance by adding up, okay, all of these numbers. If we add these up, we get 6,913.69. Okay, and to find an average, we take the sum, which is the 6,000 number, and divide by the total number of days, which is 31. So I'm just going to scroll up here. So it says find A, average daily balance. So for the average daily balance, I'm going to take 6,913.69 divided by 31, and that gives me $223.02. So notice that's just the average daily balance. It does not mean that the balance was ever that amount. And if you look at the balance boxes right here in that column, those balances were never exactly 223.02, but we use that average just to calculate the charge on the account. So the next step, B, is the finance charge for the month. So the finance charge is going to be the percentage rate, which is 1.5%. So 1.5% as a decimal would be 0.015 times the average daily balance, which is the number that we found on the previous step. And you end up getting $335. That's the finance charge. And last but not least, the new balance. Now, this is another area where I see students commonly make mistakes. What they'll do is they'll take this average daily balance, which is right here, and then they'll add the finance charge to that. Remember, that's just the average. So what you want to do, and let me get a different color so it's really clear, is you want to take the last balance of the month, which is that 281.63. That number is the number that you want to use, because that's, you want to actually pay your balance, not the average, what you actually owe. So $281.63, and you're going to add that. And I don't need parentheses. I don't know why I use parentheses there. You're going to add the finance charge of $3.35, and then that's going to give you $284.98, and that's your new balance. So that's what you actually have to pay. So the reason that we calculated the average daily balance is just to find the finance charge, and then the new balance is what you actually owe the credit card company, plus that finance charge. So I hope that helps. As always, if you have any questions as you're going through these problems on your own, don't hesitate to ask. I'm here to help.